Hello, this is Erica and Serena. We wanted to investigate the eigenvalues and eigenvectors of songs through the audio waveform. Wave files store audio data in a vector format. For example, when we read in this audio file using MATLAB's audio read method, we get two columns of a lot of data. Each column represents an audio channel, in this case, the left and right channels, and each value represents the amplitude of the audio waveform at that point in time.
We started our analysis with Frozen's Let It Go because we wanted to find what exactly about this song was so endearing to young children. By using singular value decomposition, or SVD, we are able to extract the most important bits of each song. SVD breaks down a non-square matrix A into the eigenvalues and eigenvectors of square matrices AA transpose and A transpose A. The eigenvectors of AA transpose are stored in matrix U. The squares of the eigenvalues in both AA transpose and A transpose A are stored in sigma, and the eigenvectors of A transpose A are stored in V. By multiplying U, sigma, and V transpose, we get our original matrix A.
When we applied SVD to Let It Go, we first had to reshape our audio data since a 10 million by 2 matrix is incomprehensible to MATLAB. We used MATLAB's SVD method and removed all but the 10 largest eigenvalues. By recomposing SVD, we generated this audio sample. In this audio sample, we can hear two predominant notes.
We then looked at other songs. This is Edward Elgar's Introduction in Allegro. From which we got This is Never Shout Never's Trouble.
She's got my heart tied in a knot and my stomach in a whirl, but even worse, I can't stop calling her. She's all I want and more.
From which we got This is the prelude of Bach's Cello Suite No. 1. From which we got
With all of these, we were able to faintly hear the notes that make up each song's primary chord. For those of you who are somewhat versed in music theory, we found that the emphasized pitches were generally the notes found in the 1 chord of the song's key. The only exception in our little set of songs is Bach's Cello Suite No. 1, which, if you're curious, emphasizes the 4th and 7th of the key. Those notes are unusual notes for a piece to center around, which begs the question, why are these notes so important in this piece?
We never found what made Let It Go so popular, but we did find that the keys and musical structure defined in music theory are mathematically represented in audio files. We will leave you with the most interesting of our findings. We operated on Preludium of Schoenberg's Piano Suite, Opus 25, which is a 12-tone piece. This piece has no tonality and tries to use all 12 pitches somewhat arbitrarily. By looking at only the first 3 eigenvalues, we get the pitches F sharp and D, which is a tritone. These two notes are half of the 12 tones apart, showing the intended uniform distribution of the notes in the piece.